Okay, like we talked about in the Introduction to Advanced Internal Ballistics video, there's basically two main things that are really going to throw you off when you're doing your long-range shooting due to internal ballistic inconsistencies. One of them is bore axis shifts. That's the actual direction the bore is changing before the projectile leaves the muzzle, and that can be affected by harmonic and vibratory inconsistencies as well as muzzle brake pull-off. And that's what we're going to discuss in this video here. Also, the other thing that can affect the projectile leaving the muzzle is muzzle velocity variation, and we'll get into that a little bit later. But for right now, we're going to focus in on bore axis shifts. Now, if you guys are familiar with the video I released a lot earlier on the harmonics and vibrations in a rifle earlier in the series, you probably already got a good introduction to this topic. And you should be able to keep up with what we're talking about. So if some of the things I'm talking about sound a little foreign or weird, I would strongly recommend going back in the series and starting with the earlier videos, because like any other class, this definitely builds on itself. And like when you're talking science and math, you can't really skip some of the foundational work, or a guy will be really, really confused. So this video is at a level to where I'm assuming you're already pretty much familiar with the basic patterns and harmonics that go on when a rifle is vibrating. So we're going to discuss in more detail the harmonic and vibratory inconsistencies that happen. Now, every rifle is basically going to be vibrating and have harmonic waves going through it. The matter is being able to make sure that everything is perfectly consistent, so that when the bullet actually exits the muzzle, it's going to be riding that wave in exactly the same exact point from shot to shot. And the inconsistencies in your harmonic and vibratory motion of your rifle are what's going to change your point of impact, because the end of your muzzle is basically experiencing the vibration. That's kind of an anti-node region. And that's where you're going to have maximum flappage back and forth, if you will. You're going to have the maximum vibration at the muzzle, as compared to a point of tension on a free-floated barrel, for example, by the receiver. That's going to be fixed to a larger, more rigid part of the rifle system. So on the far end of any solid vibrating object, you're going to have definitely an anti-node region where you have more vibration. That's why your muzzle is constantly changing the direction of the bore axis. So when we're talking about addressing these bore axis shift problems, we're not really talking about eliminating bore axis shifts. That's kind of impossible on a standard rifle system, unless you're going to completely redesign a rifle from the ground up to where most of the mass would be towards the muzzle. So the way we're going to skin this cat is basically to make sure that our harmonic and vibratory nature of the rifle system is as consistent as possible, so that when your projectile exits the muzzle, it'll be exactly in the same spot of vibration each time. And that's how we're going. And that's why things like developing loads when you're reloading and selecting the right ammunition and harmonic tuning is so important. So the main things we're going to be addressing here is talking about deleting the main inconsistencies in a rifle system, talking about rifle system rigidity, problems that arise that lead to inconsistent whip action of the barrel. And so that's kind of the culprit there, is you got a whip action on your barrel, and you got to make sure that it's absolutely consistent so that you can time your loads to match that. Another thing we're going to discuss here when we're talking about the harmonic inconsistencies that can change the axis of your bore is poor rifle deployment. And we're going to talk about, that's basically recoil action. Before the projectile actually leaves the muzzle, your rifle begins to actually move around under recoil. And that's what we're going to call this inconsistent jump action on recoil. And depending on how your rifle system is deployed will kind of determine how consistently it will recoil. And that will, if your rifle is recoiling different each time due to poor deployment, what you're going to have is a different axis of your bore from shot to shot at the time the bullet exits the muzzle. When you touch the round off, your crosshairs might be exactly on the target, but before the bullet exits the muzzle, under recoil, it's going to have moved significantly, and hopefully it's moving in exactly the same spot, and that's how we get our consistency. And the other thing that doesn't really have anything to do with a harmonic or vibratory inconsistencies, but it does still change the axis of the bore, is muzzle brake pull-off. And hopefully we're going to address that in pretty good detail here as well. So let's get started, and let's start talking about, we're just going to focus right now on the harmonic and vibratory inconsistencies due to rifle system rigidity issues, okay? So basically what we have going on is inconsistent whip action. Now, just as a recap here, whip action I'm talking about is the movement of the projectile can kind of cause a whip action, which means that the axis of the bore at the muzzle in the vertical plane, particularly, when the projectile leaves, is different to the axis before firing. And actually, this doesn't only have to be vertical. This can also be horizontal as well, which can really throw you off. You got to remember, when a rifle system is vibrating, it's not just vibrating on a unidimensional plane. The vibrations are not only going to be up and down, but they're going to be side to side as well, obviously. So some things we're going to talk about here with inconsistent whip action, things that can cause that are rifle dynamics, like as far as your barrel and stock contact points. You can have stock warp, which can cause different kinds of pressures against the barrel, which can totally change how the whip action is going on there. And the lockup of the bolt lugs can change this, the chamber dimensions and headspace. And also we're going to talk about other things as well, like bore and projectile dynamics and ammunition inconsistencies. Those are things that are all going to really play into each other and affect the overall rifle system rigidity. Now, a change in any one of these things can totally change the harmonic nature of how the rifle vibrates. And that's you want it to be vibrating absolutely consistent as possible. So let's talk about rifle dynamics for starts, okay? So one of the major things we can talk about is barrel and stock contact points. This is one major cause of inconsistency in the vibration nature of the rifle. And what I'm talking about here is if you have a rifle where the barrel, this is particularly true on some of the cheap injection molded plastic stocks or some of the wood stocks that are poorly fitted to the rifle and barrel. Sometimes when they're manufacturing these things, they don't take a lot of care into the bedding of the rifle or into the channel of the barrel, where the barrel fits through that channel. And there's two different ways to really fix this problem. And what we're talking about is you have contact points between the stock and the barrel along the length of the barrel. And as your rifle is vibrating, those vibration waves can be very, very problematic if they do cause the barrel to come into contact with the stock at any given point along that channel. What happens is you have a consistent vibration down the barrel and a consistent whip action being produced from, basically the vibrations. And sometimes there's just a tiny minor variation in some kind of, in the ammunition or how the ammunition was laid in the chamber or the burn rate of the powder, but it changes your pressure curve, and that can change the harmonic nature of exactly where the antinodes and nodes are vibrating along your barrel. And if those change, sometimes there's spots in the stock, the rifle stock, that come closer to the barrel. And if that would happen to touch the barrel while it's vibrating, just like it would be if you pluck a guitar string and you reach over while it's ringing out and you just barely touch it, you can totally change the nature of that vibrating string, and that'll completely give you a completely different sound out of that string. Well, the same is true with the barrel. If you have 3 shots in a row where you have the same exact tune, ringing down the barrel, and then on that 4th shot, you kind of touch it halfway down the barrel, it's going to put a damper on the harmonic vibration, and that can totally change the axis of your bore at the time the bullet leaves the barrel, and that can throw off your point of impact dramatically. So what you want is a consistent relationship between the barrel and the stock, and there's 2 ways to accomplish that. And basically, the one way, and we talked about this briefly in our harmonics video earlier, you can introduce points of tension that are solid points of tension along the barrel. And that's one way of taming that down. And that does 2 things. That sort of reduces the amplitude of the antinode regions at the muzzle. So your vibrations, the actual physical distance your muzzle is flapping back and forth, will be reduced, although the frequency, the speed at the flapping will be increased. And that's just the physics if you look at harmonic waves and things like that. But so that's one thing you can do to reduce the amplitude so that the nature of the point of impact shift will be just smaller, okay? So you can either introduce tension that will make it more consistent, so that way, from shot to shot, you'll always have a good solid barrel tension up at the front of the stock, for example. And that will cause consistent whip action. That's what we're looking for. You're going to have whip action one way or the other. That's one way of making it a consistent whip action, something that you can match a load to, and then it'll usually be there, or it'll stay there. You know, it's not going to move around on you. The other way to solve this problem is what they call free-floating the barrel. And that's where you remove enough material down the stock channel to where your barrel can basically ring freely. It can just vibrate all at once, and it's never going to touch the stock forward of the receiver. And what that does is that allows consistent whip action. That's actually probably the more common way of addressing this problem, is just free-floating the barrel. And that's not too hard to accomplish at home. You can probably look into, I'm not going to show you how to do it here. There's a million videos probably showing you how to do that. And you do need more space. A lot of guys use a piece of paper or a dollar bill to see if there's any contact points between the barrel and the rifle stock. But a dollar bill is not really enough thickness. You do want more space between the barrel and the stock, especially when you get towards the forend, because as you get further away from the receiver, you're going to have a greater amplitude of vibration. So especially towards the front, you're going to want quite a bit of room up there, because that thing can be kind of vibrating quite a bit. If you were to watch it on a super slow motion camera, you might be surprised, like, holy smokes, that barrel is not as solid as I thought it was. It's vibrating quite violently. And what you want to do is make sure that you have plenty of room for that thing to flap back and forth to where it's never going to ever have a possibility of contacting the stock. And that will give you consistent barrel whip action as well. And that can be very, very helpful for eliminating this problem. Okay, so if you had to make a choice between the two things, like what should I do, free float or introduce pressure, like totally bed the stock against the barrel, if I just had to give a blanket statement, I would say free floating is probably the safer way to do it, because then you eliminate a whole possibility of other problems that can arise. And that brings us into our next subcategory here of rifle dynamics when we're addressing these bore access shifts due to harmonic problems, and that's stock warp. And this issue is mostly applicable to rifles where the barrel is more solidly mated to the stock, especially in the front. This can cause major problems in the field. Let's consider 3 different kinds of rifle stocks, or maybe even 4 here. I'm just kind of going off the top of my head as I'm doing these videos, so I'm trying to organize it for you as best I can. But let's start off with a wood stock, okay? A classic hunting wood type stock. Obviously, wood is subject to warp over time. More pertinent to a long-range shooter is the stock that happens from day to day due to changes in temperature and humidity specifically. If you look at wood in a microscope, it's made out of plant cells, right? You got the xylem, basically, of the wood, and there are a bunch of little pores, and them things can soak up a lot of water, and that can change the dimensions of those individual wood cells, and that can cause the stock to change its shape and dimensions as humidity changes. Now, if your barrel is in contact with the stock forward of the action, this can cause some major problems, because you're going to have different amounts of barrel tension going on down the stock. So that's one reason why I would recommend free-floating your barrel, because then you eliminate the whole problem of stock warp, especially if you're using a wood stock, unless it's very well sealed or something, or it's a really, really nice piece of wood that it's not like some of the older wood is actually better because it's got most of its warping done, but it can still be affected by temperature. And this can depend on how much linseed oil finish you can have on the wood as well. You can use, I've had great success with wood stocks performing very well, but you do have to be aware that in the field, especially if it's a real hot day or a real humid day, that can change your barrel tension enough to change your point of impact significantly. So if your pattern on the paper is a little different from one day to the next on your wood-stocked rifle, that's probably the cause of it. Might not be a problem for hunting large game at long range. Like if your standards of accuracy only need to be 1 minute of angle, that's not going to probably hurt you too bad. It can. Sometimes it can be dramatic how much stock warp can change your point of impact. But for, if you got everything squared away up there and you have good consistent stock tension up there, if you've got a fully bedded barrel all the way up to stock, it's going to be reduced. But if you're trying to hit real small targets, or if maximum precision is your aim, then I would recommend just eliminating the problem and either completely changing stocks. There's something a lot less apt to being warped, like a high-quality fiberglass stock or an aluminum chassis system of some kind. Those will pretty much eliminate your warp issues. But if you really like to use wood, you might want to just free float your stock. That's probably the most safe way to go. Some of the injection molded plastic stocks, they're less apt to the warp that wood encounters, but they still are subject to warp. Specifically temperature. They can change shape with temperature, and if you have barrel tension underneath on a plastic stock, I'm talking about the injection molded stocks, is different than like a Macmillan fiberglass stock is a totally different thing than an injection molded plastic stock. And on those, what you have happen is basically a lot of times you'll have a point of tension forward in there underneath the barrel, and with temperature, the nature of the plastic changes. It becomes more plastic. And when I say plastic, I don't mean by plastic. I mean by plasticity, the ability of that stuff to deform. You know what I mean? Know what I'm saying? And if your plastic stock gets really cold, in cold weather, it can get a lot harder, and it'll stiffen up a little bit. So that'll totally change how your rifle barrel will vibrate, especially if you have any kind of tension up there or any contact points on your injection molded stock. So if you got one of those things, those are actually worse than wood, in my opinion, as far as the harmonic problems that arise. So if you got an injection molded stock, you definitely want to make sure it's free floated up there. I wouldn't even mess around with trying to glass bed one of those things, because plastic is that injection molded stuff is just goofy the way it works. It changes more than you would think it would. It's not really as rigid. It's not up to the rigidity standards we're going to require. So particularly on those types of stocks, just go with the free floating. I wouldn't mess with glass bedding it or anything like that. Another kind of stock we can talk about is like this Macmillan A5 here. This is a really, really good choice. It's fiberglass, and it's really solidly constructed. Some of the injection molded are kind of hollow, and they're skeletonized on the inside because they're cheap and they didn't want to use so much material. They're very lightweight. And what happens is your rigidity on the injection molded plastic stocks is really crappy. It's really, really low rigidity. But on the Macmillan type fiberglass stocks, or some of the HS Precision stocks, some of the more high quality composites, you have really, really good rigidity. And it's a solid piece of fiberglass for the most part. And what you have is a lot of weight. And some of these are built really thick, too, like this Macmillan A5 here. This sucker is really, really thick. So your rigidity is, like, really, really good. And that's going to reduce any of the warp. You're not going to have stock warp problems with one of those. So if you wanted to glass bed a barrel to one of those types of stocks, that would work quite well. However, on my precision rifles, I still go ahead and I free float just to make sure. Because along with stock warp, there's another thing that can happen. You can introduce a warp to the stock just by applying pressure, inconsistently on the forend. For example, if you're holding the rifle differently from shot to shot and your barrel is not free floated, there's still going to be a difference of pressure on that forend of the stock, and that will change the harmonic nature from shot to shot of your barrel. So unless you plan on deploying that rifle exactly the same each time, that can cause some problems. So that's another major reason why most guys do go for free floating the barrel, because then you can introduce tension to the forearm of the stock. And the point of the stock up there is you have a rest. You can lean it against something, when you can hold it with your hand. You can deploy a bipod, and it's not going to directly affect the tension against the barrel. It's still going to throw off your harmonic nature of the entire rifle system, as we'll see in a minute here, but it's not going to directly affect the barrel part, which can really throw you off. So even the really solid stocks like the chassis systems and stuff like that, the whole point of those is to just get everything away from the barrel so that when it vibrates, your last point of tension was at the receiver, which is totally, that's going to be solidly mated, and you're not going to have vibratory inconsistencies introduced along the length of the barrel, because that can be a nightmare to deal with. So the best way really to take care of this, in my opinion, is to free float the barrel from the stop. Just get rid of all those possibilities. Then you can, be at peace or whatever when you pull the trigger. You don't have to worry about all that stuff. So the next thing we can talk about here when we're talking about rifle vibration dynamics is the lockup of the bolt lugs. Now, what I'm talking about here is if you look at a bolt on a bolt-action rifle or even on an auto, you have bolt lugs, that's what kind of locks the bolt into the receiver, so that when you shoot, it doesn't just fly back, right? So you got to have a lug up there. And what you have on most factory rifles is you have decent lockup. But sometimes you can have inconsistent mating at the rear of those lugs against the little tracks in the receiver. And what that can do is as your cartridge starts burning and your pressure starts building up, that's going to produce a huge amount of force going backwards against the face of the bolt. And that will cause some metal stress, and you will have a slight expansion to some metal. And all these things, like we talked about on the video before, are going to totally change the harmonic nature of how the rifle system vibrates as a whole. So what you want is, like I said before, absolute consistency between all the different parts that could be moving. So, for example, you have two lugs on the back of this bolt here, right? Let's say the right side is more firmly mated up than the left side's a little loose. Well, if it's a little loose on one side and tighter on the other side, what you can have is when the rifle starts vibrating, before the bullet exits the muzzle, you can have two surfaces kind of pounding up against each other, and that can really introduce some strange anomalies in the vibratory pattern of the harmonics, and that can throw off your accuracy quite tremendously, actually, sometimes. What a lot of guys do, if they get a bolt-action rifle and they want to have it accurized by a gunsmith, is they'll take it in and they'll have the bolt lugs lapped. And they just basically put like what is it called? An abrasive compound on those lugs, like a rouge type stuff, and they'll put it in there under spring tension so that it's pressing backwards against where the lug surfaces are, and they'll work that bolt back and forth, and it just smooths down the two surfaces so that they're perfectly mated against each other. That way you have absolute consistency between both of the different lugs, so that when you rack around in, it's just nicely mated up in there, so that every time you have that full expansion of the gas, inside the case, and that produces all that rearward pressure against the bolt face, it's going to be uniform each time. So it's not going to produce like a harmonic anomaly one time, and then the next shot you have a slightly different pressure dynamic, so it's going to completely change it. Because as these, you're going to have variations in pressure from load to load due to all kinds of microscopic inconsistencies that are basically beyond our control. And those little tiny inconsistencies can be severely amplified due to inconsistencies in the mechanical nature of how the weapon is mated up against itself. If you have any kind of loose parts anywheres in any of the crucial components of your rifle system, that's going to cause severe problems. So if you're trying to accurize your rifle, basically you want to make sure everything is rigid as possible, nice and tightly mated together. One example of a severe problem you can also have, talking about different kinds of stocks, is if you have a two-piece stock, or you have a butt stock and then a fore-end piece, like on the short Model Lee Enfields, or on some of the Remington autos, or some of these other rifles where you have the rear, or Ruger number 1. If you have one of those stock pieces where the screws are just even a hair loose, particularly on the butt stock, it can be just barely, like a quarter turn loose. That can cause huge, huge problems in your rifle vibrations. And it throws a monkey wrench into the whole formula. And what you have going on is you can have 6 minutes of angle accuracy all of a sudden. And And the guy will try to figure out what in the heck is going on. Is my scope loose? Is my scope broke? A lot of times optics will get blamed for that, or the mounting. They'll go through the screws. You look for your rings. You think your ammo's bad. Did I hurt my bore? What the heck happened? And it's just one loose screw in the buttstock. So if you have a two-piece rifle stock, you definitely want to make sure everything's real nice and snug at all times. And on certain crucial parts like that, you probably want to use a small amount of Loctite to make sure that stuff doesn't wiggle loose as easily. You don't want to just drench it in there. But making sure that all your screws are tight is absolutely crucial to producing good accuracy, because you want to make sure those harmonic vibrations are as consistent as possible. And for anyone who's into music or anything like that, plays an instrument, knows that it only takes a tiny hair of a difference in any component to completely change the vibration dynamics of a solid object. For example, on like a Gibson Les Paul guitar, there's a lot of design that went into how that thing resonates. It has a real nice tone to it, and you get a lot of resonation. And even like in the trim on the outside edge of the guitar, you might have that real pretty trim on the outside. Or like on my Ibanez, like the neck, how the neck mates up to the body of the guitar. They can do like a neck through design to where there's less screws and it's all mated together. That stuff, small details, even the finish on a guitar, for example, like if it's a matte colored finish or a glossy colored finish, that will even change the harmonic and vibratory nature of that solid object. Now, the human ear is very discerning, and you can hear the difference. A rifle, when you're talking long-range shooting, you'll be able to discern the difference by point of impact shifts of a foot or two at long range due to harmonic problems. So if you're aiming at small targets at long range, this is all stuff you definitely want to make sure you got squared away. So you want to make sure that your barrel is vibrating completely consistently. The best way to take care of that is just by free floating. You're going to want to make sure you don't have any stock warp issues. And that can also have an effect on the bedding of the rifle too, especially some of the problems with the injection molded or wood stocks is compression of the individual cells over time, or the compression of the material. And that can cause things to loosen up as well. So you got to go through it constantly and check your screws. Some guys solve this problem by aluminum bedding. And that's where some of your chassis systems are real popular. So you got a solid piece of metal mated up against a solid piece of metal in a V-block, and you tighten it down, and it's really not going to change throughout the service life of that weapon for the most part. So that's probably the best way to get around that, is just a high-quality rifle stock. You don't have to do it that way. You don't have to spend the money. I've got some excellent performing long-range rifles that have a stock that's just walnut. And if you keep on top of it and you make sure everything's tight and you take care of some of the problems, it'll work just fine. So you don't need to spend, $300, $500, or $1,000 on a high-quality stock if you want to get this kind of accuracy. You just need to pay attention to what's going on, make sure everything's tight, and make sure that these particular problems that I'm addressing in this video are addressed, and you'll be fine. Another thing that's probably worth mentioning here when we're talking about rifle dynamics on solving the problems of inconsistent vibrations is chamber dimensions and headspace issues. Different kinds of rifles will have different size chambers. Sometimes you have a loose chamber where they cut out more material, and sometimes you have a real tight chamber where they cut out less material. And this can result in differences in headspace. Now, if you don't know what headspace is, I can explain this real quick. Is basically when you drop that cartridge into the chamber, you have the bolt face and the rear keeping the cartridge from going backwards. The thing that keeps the cartridge from going forwards is usually like the shoulder of the case or sometimes the rim of the case. And how much slop and play you have in there, that's what guys are talking about when they start bringing up head spacing. If you need that to be the correct distance. You don't want it too tight and you don't want it too loose. If it's too tight, you're going to be ramming, that case is going to get squashed in there, and that can cause huge problems with pressure. And if it's too loose in there, you can have the case like tear in half and explode and rupture, and all kinds of things can happen inside there that'll cause other problems as well. So you need the proper headspace. But within the proper headspace dimensions, you do have still a variation in chamber dimensions. So different brands of rifles will have different chamber dimensions. Most guys, for target shooting purposes who are looking for maximum accuracy, prefer chambers on the tight side. And that means that you're going to have less wiggle room between your brass case and the walls of the chamber. and how that plays out with it's obvious how that plays out, really, if you think about it, with your harmonic and vibratory nature, is if your cartridge is mated up the same exact way every time, if it's tight, it only has one spot to go, right? So every time it shoots, it's going to produce a real similar harmonic wave originating from the chamber there. If you have a loose cartridge that fits kind of loosely in the chamber, that thing can kind of be oriented in a multiple different ways inside that chamber. And you could have quite a difference in harmonic and vibratory signature of originating from that area. So a tighter chamber is just going to give you less problems as far as vibrations are concerned. However, there's another consideration to take into account here, and that's you don't want too tight of a chamber for any of the serious purposes. When I'm talking, like, if you're going to depend on this, if this is a weapon system, you're going to need to have enough room in your chamber to reliably be able to chamber those rounds without frictional resistance. Sometimes you have variations in ammunition to where certain rounds will not even fit into the chamber. And under extreme circumstances, in combat, this could be very, very problematic. Obviously, you definitely want the round to be able to go into the chamber. So if you're, even if you're hunting, a lot of hunters prefer to make sure that they have adequate room in their chamber, and this can be addressed to by how you size your cartridges if you're reloading. Most factory ammo you purchase is going to be fully sized, which means that the case is going to be a little bit smaller so that there's enough room for it to fit in there with no problems. Some guys who load target loads for target shooting purposes, they will only neck size the case to where the case fits much more tightly in the chamber, and that reduces your harmonic and vibratory inconsistencies, although it does increase the likelihood that you could experience somewhere along the way a cartridge that was too tight to really successfully chamber. So if you're using this for a battle rifle, or if you're using this for police or military applications where you're going to depend on this weapon system, you definitely don't want a chamber that's too tight. And you don't want to use ammunition that's really loaded to target shooting specifications. Probably you probably don't want to neck size your cartridges. You're going to want to do full length resizing and just err on the side of reliability, because in combat applications you can't afford to have rounds getting stuck in the chamber, or problems like that are really, really bad news for you. So again, I should probably reiterate that the secret to dealing with these harmonic and vibratory inconsistencies that affect the axis of your bore before the projectile leaves the muzzle in internal ballistics, like we're talking here, the trick to solving these problems is absolute consistency. And when we're talking about the rifle system itself, the main ways to solve those problems are to pay very close attention to make sure everything in the rifle is put together nice and solidly. Everything's mated up nice and tightly. You have no loose screws. You have a good quality stock that's not changing its bedding from shot to shot. So if you have a stock that's giving you problems, you probably do want to replace it or have it glass bedded. That will usually fix it. You probably want to have your barrel free floated, if that's giving you any problems. And the way you can test this usually is just to go out and start shooting for groups. That'll give you a pretty good indication of whether or not you're having harmonic and vibratory inconsistencies. If you can go out and consistently shoot half-inch groups all day long, half minute of angle, you don't have any harmonic or vibratory inconsistencies that are going to throw you off. So that's the test there. Just go out and shoot at some paper and see how well it's really shooting. If you are having problems, that's indicator that you have harmonic and vibratory inconsistencies. And then you can go through and start eliminating these problems. So your number one thing is basically your bedding of your stock. You want to make sure your action is completely solidly mated to the stock. You don't want the barrel to have inconsistent contact points, so that your whip action of your barrel is absolutely the same from shot to shot. You want to make sure that the lockup of your bolt lugs is consistent from shot to shot as well. And that can be fixed by lapping the lugs if needs be. That's probably the last thing I would worry about. Free-floating the barrel and bedding the action is probably going to take care of most of your problems. Your chamber dimensions, that's something you don't really have a whole heck of a lot of control over, except when we're talking about our ammunition that we're going to select for the rifle. And we're going to talk about that in just a minute. So that kind of sums up some of the harmonic and vibratory inconsistencies that you might experience due to problems with your rifle. And hopefully that gives you a better idea on how to take care of some of those things. And as far as the different rifle dynamics goes, that's something you can pretty much take care of when you get your rifle initially, and then you should be good to go after that. The next category of things that we have to be aware of when we're talking about harmonic and vibratory inconsistencies due to rifle systems is the bore of the rifle and its relationship with the projectile. And that's something that can change from day to day is your bore condition. So that's something that we're going to look into on this next video coming up here. We're going to look at bore condition and how wear affects the relationship between the bore and the projectile, fouling and coppering. We're going to talk about bore temperature and projectile temperature, things like that. And that can change the frictional dynamics of how the projectile is going down the bore, which can totally throw off our pressure curve, which can produce a totally different harmonic signature in our rifle system, which will basically throw off our bore axis. And so that's the next big topic. After that, we're going to discuss ammunition and inconsistencies with typical ammunition. Then we'll be into poor rifle deployment issues, and also we'll talk about muzzle brake pull-off. And that will sum up the section on advanced internal ballistics on bore access shifts that are experienced. So stay tuned for the next video on bore and projectile dynamics.